Good morning to all. In this session, I am going to discuss about the sorting mechanism. So this particular video, we are going to discuss about the introduction part related to the sorting. What actually is sorting and what are the advantages we have for the sorting, and how many types of sorting we have. Of course, we have so many sorting algorithms that are available in the data structures concept, but we will be confining ourselves to our syllabus part, right? We will be discussing about the bubble sort, insertion sort, selection sort, quick sort, and merge sort. So let us start our discussion on sorting. So sorting is a process where you are going to arrange the elements in a specific order. So sorting does not confine itself to only numbers. You can also have the alphabets, you can also have the strings. You can apply the sorting on numbers, or you can apply the sorting on alphabets also. If you apply the sorting mechanism on numbers, you can sort the things in two ways. One is the ascending order, and second one is the descending order. Ascending means we know this thing very well, lowest to highest, and descending means highest to lowest. Sorting, when applied on numbers, you will be arranging them. The end result, you will get it as the ascending order or the descending order. But I told that the algorithm, the sorting, can also be applied on alphabets. So when you apply the sorting mechanism on alphabets, you will get the list of elements that are arranged in the alphabetical order. Or we can also say it as dictionary order. So in dictionary, you can see that all the words and the meanings which you want to find, they are arranged in the alphabetical order. So all the things that come with this A, they will come at one point, and all the words that come with B will come at one point, like that. That is called as the alphabetical order. So remember that whatever examples we are taking in this particular explanation part is based on the numbers only, but you can also apply the same techniques on the alphabets also. Sometimes you may be asked to apply the sorting algorithms based on the strings or the alphabets. So you should be in a position to apply the theorem or to apply the mechanism of sorting on any of the data, whether it is numbers or alphabets. Right. So this is the definition of sorting. We already discussed that sorting algorithms are used to arrange the random data into some order. So sorting can also be called as ordering. In the previous sessions also, we have seen that for implementing the binary search, you need to consider the ordered array. Ordered array means sorted array. Whether the list can be in the ascending order or it can be in the descending order. But sorting, other name is ordering. So how they are being sorted? The elements are sorted based on a particular way. There is some mechanism. Whether it is in the ascending order or in the descending order, or in case of the alphabets or strings, you will be arranging it in the dictionary order. So generally the collections of data are presented in a sorted manner. We have so many examples where we always store the things in the sorting order. So if you go for the books in a library, they are arranged in the, may not be in the dictionary order, but they are sorted on based upon some branch criteria. So all the CSC books will be present at one location. All the ECE books will be located at another location, like that. So the real life examples where we can come across this sorting is the words in the dictionary, they are in the sorted manner. And similarly, if you consider the files in a directory, if you open a directory in the Windows operating system, if you have some n number of files, you can observe by default the operating system will be arranging all those files in the sorted order, alphabetical order. Similarly, the index of a book is sorted. And whenever you go for the statements for a bank, whenever you approach a bank for getting the statements, they will give the statement slip, and that particular slip, if you can observe, they are arranged in the increasing order of dates. So the latest transaction will be present at the top, and the remaining transactions from that day to the previous dates, they will be in the sorted order. So there we are implementing the transaction slip, we are implementing the sorting on date, whereas in dictionary we are sorting on alphabets, and in files in a directory they are also sorted based upon the alphabets. Similarly, if you consider a newspaper, the calendar of events in a schedule is generally sorted by date. So bank statements, they are based on date. Similarly, the events that are scheduled in the calendar, they are also based on date. And previously we used to have the CDs, musical compact disc. And if you go to a record store there, musical CD record store, you can observe there that all the compact discs, they are arranged based upon the artists. So all the records of SP Balasubramanian will be kept at one location. Similarly, based upon musicians, like that, you will have the different compact discs arranged in some sorted order, and there we are following the sorted order based upon the artists, singer or whatever it may be, music director, whatever it may be. So these are all the examples we have seen. Now let us see why we require this sorting. In the previous sessions also we have discussed that a real life example where our mobile phone is implementing, that is nothing but the contact list. So if you have a contact list that is present in the sorted manner, then searching for your friend's contact will be very fast. Whereas if you have the contact list that is maintained by the mobile phone is not in the sorted order, then you will be ending up in a situation where to find a contact of your friend takes very large time. So that is the benefit you get from sorting. So this is the reason why we generally prefer the elements, long list of elements, to be present in the sorted order. So once we know what this sorting is, here we have seen what this sorting is. Once we know why we require this sorting, and once we know the examples, real life examples of sorted elements, let us see the complexity of sorting elements. As I told that, irrespective of what algorithm you are implementing, whether you are implementing the search algorithm or sorting algorithm or some another operation, some XYZ operation, whatever operation you are going to perform, the efficiency of the algorithm can be calculated with the help of two parameters, that is the time complexity and the space complexity. In the previous discussions also we have gone through these terminologies. So most of the sorting algorithms, they take different spaces and they take different times to execute. And when you want to compare the efficiency of the algorithm, as I told that you always have to prefer these two terms, the time complexity, which specifies or which is defined as the time that the computer takes to run an algorithm. Similarly, the space complexity, the other parameter is the space complexity, which is defined as the amount of memory the computer needs to run the algorithm. Right. So these are the two external factors you need to consider to find the efficiency of the algorithm. But other than this, we have some internal factors on which the algorithm depends, right? So those external factors, these are the internal factors, and the external factors on which the algorithm depends is, it also depends on size of the input of the algorithm. For example, if you take a bubble sort algorithm, which we are going to discuss in the next sessions, a bubble sort algorithm works very well with smaller inputs, smaller list of elements. But if you implement the same bubble sort algorithm with large list of elements, the performance of the algorithm will be very poor. So in addition to this time complexity and space complexity, you just remember that there are so many external factors like the size of the input of the algorithm, and the second one is the speed of the computer. For example, you implement or you run this bubble sort algorithm in the old processors, that is Pentium 3, Pentium 4 processor. It will take very large time. But if you execute the same program with quad core processor, it will take very less time. So the same inputs, but if you run the algorithm on different computers with different hardware, then you are going to have different time complexities. So this is one external factor that also influences the efficiency of the algorithm. And the third one is the quality of compiler. So if you run the same bubble sort algorithm on old compilers, it may take some more time. And if you run the same program with the modern compilers, it will take less time. So these are the three external factors, that is the size of the input of the algorithm, the speed of the compiler, and the quality of the compiler, the speed of the computer. All these three parameters also influence the efficiency of the sorting algorithms. Not only sorting algorithms, everywhere it is there. So remember that these three parameters are just few out of a large list of parameters we are mentioning, right? These are the external factors that influence. Maybe they are not treated as in calculating the complexity of the algorithm, but they play a very important role. They show their effect on the execution speed, like the speed of the computer or the size of the input. So we should be very careful in these external factors also. But nowadays there is no need to go for these considering this speed of computer. We have very fastest computers that are available, not an issue. So just remember that other than this time complexity and space complexity, there are some external factors which we need to consider for calculating the efficiency of the algorithm. And as I told that, the last part, what are the various sorting algorithms we have? As I told that we have different and very large set of sorting algorithms that are available in the market, or that are available in the data structures concept. But we are going to discuss about only few of our sorting algorithms which are closely related to this syllabus, to our syllabus, right? So we have different algorithms like the bubble sort, selection sort, insertion sort, quick sort, merge sort, heap sort, radix sort, shell sort. So many things are there, right? But according to our syllabus, we'll be confining to discussions on the bubble sort, we'll discuss the bubble sort, and we'll discuss the selection sort, we'll discuss insertion sort, quick sort, and merge sort. And this heap sort also we'll discuss while discussing the concept of the trees, search trees, or the priority queues. And if time permits, we will also discuss the radix sort and shell sort. So these are the important and primary sorting algorithms which we are going to discuss. So that's all about the introduction part related to the sorting algorithms. Let's have a gist or the overview of what we have discussed in today's session. So we started our discussion on the sorting with the definition, what actually is a sorting, and then we have gone through some real life examples of sorting algorithms, and then we have seen why we require, what is the advantage we get from sorting the list of elements or implementing the sorting algorithms on the list. And then we have seen how these sorting algorithms can be evaluated, how we can calculate the efficiency by making use of the time complexity and space complexity. Other than these two parameters, we also have some external factors that influence the efficiency of the algorithm, which is nothing but the size of the input, the speed of the computer, and the quality of the computer. And finally, we have listed out various sorting algorithms that are available in the data structures concept. And in the next sessions, we are going to discuss each and every topic individually with an example scenario also. So that's all for today's session. Thank you one and all for joining the session.